what can magnets pull? Magnets can attract or pull objects that have iron in them. This nail is made with iron, so it sticks to the magnet. So does this nut, screw, and bolt. Your hammer is made out of steel, which is a metal made with iron. So it's magnetic. But not all metal objects have iron in them.
Think back to your lab experiment where you took several materials and tested out whether or not they were magnetic. There were several metals that you tested that proved to not be magnetic. What were some of the examples of those non-magnetic metals?
Your coins and keys are definitely metal, but they are not magnetic. That can is made of aluminum, not iron, so it's not magnetic either. Magnets will not attract paper, wood, plastic, or rubber. Magnets may look different, but they all work the same way. What are magnetic poles? Magnets have two poles. No, not that kind of pole. The poles are where the pull of the magnet is strongest. Each magnet has a north pole and a south pole. On a round magnet, one side is the north pole and the other side is the south pole.
Magnets. This is one magnet and this is another magnet. Each magnet has two magnetic poles. The part of the magnet where the pull is the strongest. So, on this magnet, because this is technically a round magnet, this is one of my poles, and the opposite side where my VEX robotics piece is attached is my other pole. It's on the other side of my magnet. The same for this one. This is one pole. The other side, where my robotics piece is attached, is where my other pole is.
The opposite poles always attract. So the north pole of your magnet and the south pole of mine stick together.
I have two round magnets here. I'm going to tape one end of them, and I'm going to say that my lighter taped end is my north pole, and my dark end is my south pole. Watch what happens when I have the north pole of one of my magnets facing the south pole of my other magnet. So my north pole is facing up. I'm going to have the north pole of my other magnet facing up as well, so that the south pole of my other magnet is facing my magnet. The same thing happens with the two magnets that we were investigating with. The north pole of one of my magnets sticks to the south pole of my other magnet. These opposite poles attract.
But like poles do not attract. The north pole of your magnet and the north pole of my magnet repel or push away from each other.
Watch what happens now when I take my top magnet off and flip it. So now the north pole of my bottom magnet will be facing the north pole of my top magnet. Like poles always repel one another. So in the previous example, you saw my two north poles pushing against one another. They don't want to be anywhere near each other. It's the same thing for your magnets. We said that this is one pole and this is another pole. So if I were to take this side of my other magnet and try and push it on the back side of my second magnet, I will feel that repulsion or the magnets pushing away from each other. So like poles will repel, they'll push away from each other. Opposite poles will attract, they'll want to come together. If I take this top magnet off and flip it again so that the north pole of my bottom magnet is facing the south pole of my top magnet, I can do this the other way. I can have my bottom magnets south pole facing up and my top magnets north pole facing down. They'll still be attracted to each other because my opposite poles are near one another. With magnets, opposites attract. If I take my top magnet and flip it over so that my south pole would face the south pole of my bottom magnet, I have that same response from my magnets. Pretty cool, huh?
What is a magnetic field? A magnetic field represents the force around a magnet. When the nail is farther from the magnet, it's in a weaker part of the magnetic field, and the pull that the nail feels isn't as strong. But when I move the nail closer to the magnet, it's in a stronger part of the magnetic field, and the nail feels a stronger pull from the magnet.
If I had this magnet in a classroom and had an object across the room that was magnetic, that object likely would not be attracted to this magnet from across the room. I'd have to bring either my magnet closer to that object or that object closer to my magnet so that it could be within this magnet's magnetic field in order to feel that attraction. So the more powerful a magnet is, the more powerful its magnetic field. If I had a very strong, very powerful magnet in my classroom or at your home, and you had a magnetic object across the room, that magnetic object would respond more to your powerful magnet than it would to your weaker magnets.
Right, magnets can move things even without touching them. Magnets can push or pull through gases like air. They can also attract and repel through liquids and solids.